Okay, this is Dilations and this is the second video. The first video I went through all of these guys. Okay, I did a K of 2, K of 3, and a K of 4. I had the center at the origin, I had the center on a corner of the figure, and I put the center at some random spot. Okay, what I haven't done yet in that first video was I wanted to do a reduction, which would make the object smaller, and then I wanted to do one where the center was actually inside the actual original figure. Okay, so we're only going to do 2 examples here. Hopefully it's a little shorter. So let's do it on a coordinate plane. Okay, and let's just do let's do our reduction. Okay, so let's put the center here, the center of our scale factor there. And let's make this, let's put this at 4, 2. And let's make that 10 long. That's at 4, 2. Okay. And let's make it 6 high. 6 high would make that at 4, 8. Okay, have some practice, see if you can figure out these other ones. Remember, if this is 10 long from 4, 2, then now it's at 14, 2, and if you're going 6 up from here, you're at 14, 8. Okay, so you can get those 4 coordinates. You make sure it all makes sense. Okay, so it's a rectangle that's 6 by 10, and let's put the center there. The center at 0, 0, and let's make the K 1/2. Which would be a reduction, right? So I'm going to make the side legs half as big as they all were. So again, if this is not on a coordinate grid, this problem is already done. So instead of 6 by 10, it's going to be 3 by 5. On a coordinate grid, you have to pay attention to the center, okay? And we're just going to focus on this coordinate point right there. So instead of being 4 and 2, a K of 1/2, I'm just going to make it half as close to the center. So I'm going to shrink this point halfway to the center, and I'm going to get right here. And all I have to do is shrink both the coordinates by half. So instead of 4 over and 2 up, now it's going to be 2 over and 1 up. So that point is just going to be 2, 1. And it really is that easy. The rest of it, you can shrink them all, or you know already that this is 3 up, 5 over, 3 down, 5 over, and you can draw it, and you'd be done. Okay, let's look at this one though. This is 4, 8, meaning 4 over, 8 up. Now just go 2 over and 4 up, and you'd be right there. Yeah, right there. Okay, so 2, 4. See how I shrunk both of these coordinates by 2 and both of these coordinates by 2? And in this case, it's easy because it's at the center, so the coordinate is how far you are away. But it wouldn't matter. I could put the center way over here. I would just find that distance and shrink them both by 1/2. And again, I know that had to be 3 because that was 6. Again, this picture is not to scale. It's going to look bad because those lengths look almost the same even though I shrunk it by 1/2. So my bad on the picture, but the coordinates will give you the proof of everything you need. This was at 14, 2, so you're going to make it at 7 and 1. Okay, so now it's at 7, 1. And you can see it's 5 away, and you get that. Instead of 14, 8, you're going to be 7, 4. And you can check all those things and make sure that you're still 3, 5, 3, and 5 instead of 6 and 10. So again, I knew the rectangle was going to be 3 by 5 instead of 6 by 10 because that's what a reduction is of scale factor 1/2. The coordinates all shrink by 1/2 as well. If it's centered at 0. If not, then you have to pick, where this new center might be, and you're still reducing that distance. It still would be 3 by 5. It just might be shifted where it's at. And again, we can investigate. I know it's not going to look like it. My bad on the scaling here. But I still would like to look at the original perimeter of the blue, 6, 10, 6, 10, right? 32. And the area of the blue, 6 by 10 rectangle, is 60. And then I want to look at the perimeter of the new shape. 3 and 5 make 8, and then around it would be 16. And the area of the new shape, P2, not P1. Area 2 is 3 by 5, which is 15. And look what happened. If the scale factor is 1/4, 1/2, then the perimeter ratio is also 1/2. If K is 1/2, the perimeter ratio is 1/2. The perimeter gets half as big if all the side lengths get half as big. However, the area dropped by 1/4. Remember, the area ratio is always the scale factor squared. In this particular example, 1/2 squared is 1/4. You make this half as big and this is half as big, the area is 1/4 as big. And I know the red doesn't look like it's 1/4 of the blue, but I just had a bad drawing. Okay, so that was a reduction. It got smaller. I picked a center. And again, we can look at the perimeter and area ratio and see that those things are reduced to, the perimeter ratio is reduced by the same factor, and the area is the scale factor squared. 1/2 squared is 1/4. The area is 1/4 of the original. Okay, let's just do one more, and let's put the center somewhere funky, and let's actually put it inside the shape. So the shape is going to expand kind of on itself. Try to draw this one a little bit better. So, I don't know, let's make that 3, 5. We'll make that, how about 8, 5. That makes that distance 5. Okay, so that's 5. And that really maybe then it's only, I don't know, maybe it's only 3 up. So then this would be 8, 8. And 3 up would be 3, 8. All right, so it's a 5 by 3 rectangle. And I'm going to pick the center inside this silly shape. Okay, so let's do a scale factor of 2. So let's make K2. And let's make the center, we'll just put it like maybe right. How about we put it at 5, 7. So 5 would be like right there, and 7 would be right there. Okay. That's my center. 5, 7. Okay, so everything is going to get twice as big in terms of how far they are from the center. So the thing's gonna blow up that way. Again, I guarantee the new shape is going to be a rectangle, and it's going to be 6 by 10. It has to be. It has to be 6 by 10 because the scale factor is 2. So all the side lengths are going to increase by a factor of 2. It's just that the center is 5, 7. So what I'm going to do, if that's 5, 7, I'm just going to do this coordinate point right here. Now, you know what? Let's do this coordinate point right here. And I'm just going to make it then double that distance. So let's find that distance. Think about that for a second. 3, 5 to 5, 7. I go over 2. Oh, that's easy. Over 2, up 2. So that is going to expand by a factor of 2. So instead of 2 down and 2 over, now I need to go 4 down and 4 over from the center. And that will make sure that I move that coordinate point double its distance because I doubled both pieces. Okay, so then the new coordinate, with the K of 2 is going to go 4 over, so I'm at 1, and then 4 down. So what did I just say? 1, 3? 1, something like that. Okay, 1, 3. So this distance and then this distance, I doubled it. It was 2, 2, and now it's 4, 4. 4 down from 7 is 3, 4 over from 5 is 1. So I'm at this new point, and I can draw all the other points. All the other points. Now, what is this distance? For sure. We know it. It has to be 6. What's this distance? It has to be 10. The red, all the red sides, this for sure is 6. This for sure is 10 because that's what a scale factor of 2 is. It's just the coordinates themselves are also double the distance from this center. And we can check that out. Again, I already know what this, if this is 1, 3, and this is 6 up, so go 6 up from here, I'm at 1, 9. 10 over from 1, 9 is at 11, 9. Right? 10 over here is 11, 3. And you can check all the distances. This is 6 up, this is 10 over, this is 10, this is 6, it had to be. And then we can look at all the individual distances if you want to. So like this point. Compare this point to this point from our center. Right? This one went 2 over and 1 up. Yes. 2 over and 1 up to get to there. And now this point is 4 over and 2 up. I doubled it. Right? I doubled its distance. Everything is doubled from the center, which doubles all the side lengths. And again, let's look at the perimeter. Doesn't really matter where the center is. The perimeter was 5, 3, 5, 3, so that's 16. The area was 5 by 3, so that's 15. And then the new perimeter, P2, the new perimeter is 6 by 10. 6, 10, 6, 10, I almost did area. 6, 10, 6, 10 makes 32. Shocker, it's double. Of course it's double. The perimeter ratio is the same as the scale factor. And the second area, oh, I should have done that in red. Get rid of that. Area 2 is 6 by 10, which gives me 60. Again, as you can see, perimeter ratio is a scale factor of 2. Area ratio is 2 squared. 4. It's 4 times the size. The blue area and the red area happens to overlap and totally engulf it, but the red area is 4 times as big. I did this one so I could show you how to expand it from the center of some shape. The center can be wherever it wants to be. You're still going to create a side length 2 times big, so 3 by 5 goes to 6 by 10, except where it's located is based on the center, and you just move all the coordinates, double the distance they were from the center. Okay? Hopefully this kind of clears up, and kind of shows all the different possibilities of reducing things, enlarging things, and putting the center wherever you want. And again, I'm really harping on knowing that the scale factor is the ratio of all the side lengths, which will be the same as the perimeter ratio, and the area ratio is the square of that scale factor. Scale factor was 1/2, area ratio is 1/4. Scale factor is 2, area ratio is 4, right? 2 squared. Okay, hopefully this helps.